Alright, this lesson is about the relationship between arcs and angles. Some of our angles will be outside of the circle like this one, some inside, and that affects the relationships between the arcs and the angles. Just a brief overview. If the angle is has its vertex at the center of the circle, it's called a central angle. And in that case, the angle and the arc measure are equal. I'm going to be using theta to represent the angles in all of these examples. So central angle, the angle equals the intercepted arc. When the vertex of the angle is on the circle like this, it's called an inscribed angle. And in that case, the angle is equal to half the arc, which obviously means that the arc is double the angle. Now, if you look at an angle like this, that has one side of the angle is actually a tangent to the circle, this is still an inscribed angle like this one is. Alright, because the vertex of the angle is still on the circle. So the same formula still applies. The angle is half the arc. So this would be the arc that we're talking about. So if this is 200, then this angle with one side being a tangent would be 100. Now, when the angle is inside the circle, but not necessarily at the center, just anywhere inside the circle, we have to deal with two intercepted arcs. And please understand that these angles on either side here are both theta. Alright, these angles are always equal. So whatever these angles are, call it theta, it's going to equal the average of the two intercepted arcs. Alright, so the angle is equal to arc plus arc divided by 2. It really doesn't matter which one comes first, the big plus small or small plus big. For addition, addition is commutative. So x plus y, y plus x, same thing. Alright, so inside the circle, arc plus arc divided by 2. Now compare that to this. See how the formula is almost the same. When the angle is outside the circle, we still have two intercepted arcs. We have a big arc and a small arc. But instead of being arc plus arc divided by 2, the angle is equal to the big arc minus the small arc divided by 2. And you don't want this to be negative, so it makes sense that we'll have to do the big arc minus the small arc. Okay, and we've already talked about this. See the dot right here? That's what makes it different than this. Okay, this is just randomly anywhere in the circle. This one is right at the center. Okay, I spoke about this at the very beginning right here when I said a central angle, the angle is equal to the arc. So I just want to make it clear that even if I go ahead and make this x out of it, still, if this is at the center, this angle and this arc will have the same degree measure. Okay, one other thing to throw into my intro. When you have a straight line always makes 180 degrees. So if this is 80 degrees, for example, then the other angle would be 100. Alright, these two angles are supplementary. That comes up often. So for example, look at this circle. If I told you that this was 40 degrees right here, then how many degrees would this be? This would be 140 degrees. And somehow I think it's more obvious when it's at the center of the circle like this, because you can think about a semicircle. But I need you to understand that even if it's not at the center of the circle, okay? So if I gave you that this was 130 degrees, but in order to do this formula, I really need I need this angle, not this one. So if you wanted to find this angle, the correct angle, just recognize that these angles are supplementary. Alright, so if this is 130, that means this would have to be 50. And again, the idea is if you have a straight line that's split up into two angles, a straight line always makes a total of 180 degrees. So it doesn't have to be at the center for these two to be supplementary. Okay, and then you have your 50, and then you can go on and do your formula. Alright, that's the intro. Alright, let's take a closer look at problem number 1. Find the measure of the indicated angle or arc. Alright, assume segments that appear tangent are tangent. Alright, so we're supposed to find this angle right here. Guess what I'm going to call it? That's right, theta. And this is outside the circle, so that tells us that we are using this formula. Angle is equal to the big arc minus the small arc divided by 2. Okay, so that means that the angle is equal to the big arc minus the small arc divided by 2. Like so. That's 45 degrees. Alright, so that is the answer to number 1. Number 2, same thing. So, angle is equal to the big arc minus the small arc divided by 2. Alright, that's 59. So that is the answer to number 2. Alright, number 3 is a little different. This is one that's inside the circle. So when it's inside the circle like this, let's see where we are. That's going to be this formula right here. Alright, where the angle is equal to arc plus arc divided by 2. Angle equals arc plus arc divided by 2. So let's see. So the question mark here again is the angle. Alright, so we're looking for this theta. Okay, now is this the right angle for these two arcs? Yes, it is. Okay, but you have to be careful about it. But this is the angle. If I highlight this angle, it does have 175 as the intercepted arc. Okay, this angle does go with that arc. And of course on the other side, this angle is the same as this angle. And this angle intercepts the 55. Okay, so this is the right angle for these two arcs. Alright, I had to emphasize that because sometimes it's not. So you have to think about it. So anyway, we're looking for theta. And like I said, the angle should equal arc plus arc divided by 2. Basically the average of the two arcs. Alright, that is 115 degrees. So that is the answer to number 3. Number 4. Here's where kids often will have problems. I'm going to call this question mark X. That's what we're looking for. Now, the formula that we're using is still this one. The angle is inside of the circle, so angle equals arc plus arc divided by 2. A lot of times students will just want to automatically put the unknown right here by itself and then go from there. But no, people, that's not what the formula says. The formula says angle equals arc plus arc divided by 2. So which part of this picture is the angle? Yeah, it's this one, 120 degrees. That's the angle. So that's what has to go right here. So this has to start off 120 equals. Now, what are the two arcs that we're dealing with? Well, the two arcs are this guy and this guy. Okay, so x and 60. Whoa, that color's not dark enough to really write with. Yeah, x plus 60. So this is the formula that you have to use. So now that we have it set up, we just need to solve this for x. So the way we do that is to multiply both sides by the denominator, in this case 2. That way the denominator cancels out. And that's going to give you 240 is equal to x plus 60. Alright, and then of course we need to subtract 60 from both sides. So that's going to give you, what, 180 is equal to x. And that is the answer. Okay, fun stuff begins here with number 5. We're supposed to find the measure of arc QS. Okay, so we are looking for this arc right here is our target, QS. But instead of just being given numbers and a variable, we have this whole expression, 4x plus 4, that we have to work with. Okay, and I've got this 50 right here, and I've got this 12x plus 8. These are the three things that I'm dealing with. Now, this is outside the circle, so we're dealing with the formula that says angle is equal to big arc minus small arc divided by 2. So don't be scared that these aren't just numbers. Let's just faithfully set up the formula and let the chips fall where they may. So again, in words, the formula is like this. Angle is equal to big arc minus small arc divided by 2. Alright, so look at these three things. Which one of these three things is the angle in the problem? Well, that's the 50 degrees, alright? That's angle R right here. So the 50 degrees goes here for angle. So this has to start off 50 equals. Okay. Now, that leaves these two yellow things. These are both arcs, right? Alright, we got the pink arc, the blue arc. So which one of these is the big arc? Because we got to do big arc minus small arc divided by 2. Yeah, 12x plus 8, this blue arc, that's the big arc. So we need to do 12x plus 8, alright, the big arc, minus the small arc, alright. Notice I'm using parentheses. I always do that when I have a binomial or a trinomial. So small arc is the 4x plus 4. The reason why I put it in parentheses is to remind me that whatever goes here must be distributed. Okay, divided by 2. So a common mistake would be to not put parentheses and leave this as a positive 4. But we know better. Alright, if I want to write this without parentheses, there's nothing in front of the first set of parentheses, so I can just write 12x plus 8, no problem. Okay, but this, I have to treat it like it's a negative 1, and I have to distribute that negative 1. So this will make negative 4x minus 4. Okay, negative times positive is a negative. Then I can combine like terms. So I'm going to get 50 is equal to 12x minus 4x is 8x. And then we have positive 8 and a negative 4. That's 4 divided by 2. Okay, so this doesn't look so bad. To solve this, as before, I'm going to multiply by the denominator. So I'm going to multiply both sides by 2. That way the denominator gets canceled out, and I'm left with 100 is equal to 8x plus 4. Okay, so then I would subtract 4 from both sides. So that's going to leave me with 96 is equal to 8x. Okay, then I need to divide by 8. So that's going to leave me with x is equal to 12. And that is actually not the answer. I shouldn't have even put a box around that. Let me try that again. So that is going to leave me with x equals 12. And I almost got carried away and thought that was the answer. But it's not. We weren't supposed to find x. I mean, we need that. But we were asked to find the measure of arc QS. Arc QS is not x. It's 4x plus 4. Okay, so basically we have to keep going. So alright, there's no space over there. Alright, I'm going to do it over here then. We need to find QS, okay? And the measure of arc QS, that's 4x plus 4. But now we know that's 12, so that's 4 times 12 plus 4. That's 52. Okay, so the measure of arc QS is actually 52 degrees. And that is the answer to a question. So it's very common for students to see, there's a lot of places to make mistakes in this problem, so just let's review. The first one is sometimes kids want to just put the unknown here for the angle, but it's 50, so 50 goes here. The next one is a lot of times students will not want to use parentheses, and they forget to distribute the negative sign, and that wouldn't turn the positive 4. They leave it as positive 4 when it should become negative 4. And now the last one is that so many students I will see will find x, put a box around that, and call that the answer. Forgetting that they were asked to find QS, which is actually 4 times x plus 4. So you have to plug it in to really find QS. Alright, so there was a lot of moving parts to that question, so please be careful when it's your turn. Okay, here is another expression, another problem involving expressions, alright, instead of just numbers. So first we have to decide which formula we're dealing with. Nope, not that one. Not that one. Kind of. It's this. Alright, we're looking at an inscribed angle whose vertex is on the circle. So this is just the situation where the angle is the arc divided by 2. Okay, so we've got these two things. We've got this and this. Okay, and so the formula says that the angle is equal to the arc divided by 2. The angle is half the arc. So which one of these is the angle? Yeah, the 5x minus 1. It doesn't fit really small down here, but this is clearly the angle. So 5x minus 1 equals. Okay, that just leaves the arc. So yeah, clearly the MK here is the arc. That's your 8x plus 14. So 8x plus 14. Angle equals arc divided by 2. So we just have to solve this equation. We can do that by multiplying by the denominator, as we often do when you have a denominator, okay, on both sides. So these are going to cancel out. Please understand you're going to have to distribute this. Okay, so this is going to become 10x minus 2, don't forget to distribute, is equal to 8x plus 14. Alright, some kids will say, well, shouldn't this be 16x plus 28 because you're multiplying by 2? No, that 2 got canceled out. It's not around to multiply anything. Alright, I see that I have variables on both sides, so I need to get them together by subtracting 8x from both sides. So that will give me 2x minus 2 is equal to 14. Alright, these canceled out. And then I will add 2 to both sides, so that'll give me 2x equals 16. And then I will divide both sides by 2. Okay, and that is going to give me x equals 8. Now, do I put a box around this? Is this my final answer? No, it is not my final answer. We have to look back and see what we were asked to find. We're supposed to find the measure of arc KLM. Alright, that's not even one of these yellow things, okay? So our target is what I'm about to highlight right now. KLM is the major arc that goes this way. Okay, this is what we have to find. So what are we going to do? Well, let's find the blue arc, MK, and subtract from 360. So that's our strategy. So first we'll find MK using the 8. Okay, so the measure of arc MK is equal to 8x plus 14. So that's 8 times 8 plus 14. Keep forgetting that. So that is 78. Alright, so that's the measure of arc MK. So that means this is 78 degrees, the blue part. So if I want to find arc KLM, the fuchsia part, I'm going to subtract this from 360. Okay, so if I do 360 minus 78, that's 282. And that's what you can put a box around. Because that's the answer to number 6. Okay, so we have another problem involving these wonderful expressions. I love them. Alright, so which formula will we use for the structure of this problem? Nope. Alright, this is the one. We're inside the circle. Angle equals arc plus arc divided by 2. Okay, so look at these things. Alright, the formula starts off angle. In fact, I'll just write it down. Angle equals arc plus arc divided by 2. Notice I don't say big arc and small arc when I do this because it doesn't matter. Alright, but which one of these is the angle? It's the 2x minus, I'm sorry, the 26x minus 2. So that goes here. Okay, and of course the other two arcs are the 131 and the 18x plus 1. Okay, plus 131. So this is the formula that has to be solved. Okay, I like to combine like terms immediately. There's nothing in front of these parentheses, so I'm just going to erase them. So I've got 26x minus 2, 1 plus 131, so I've got 18x plus 132 divided by 2. What's my next move, you say? You know, I'm going to multiply by 2 to cancel this out. On both sides, don't forget to distribute. These 2's will cancel out. So I'm going to have 52x minus 4 is equal to 18x plus 132. Now I see I have x's on both sides of the equation, so I will subtract 18x from both sides. So that's going to be 34x minus 4 is equal to 132. Now I will add 4 to both sides. So that'll give me 34x is equal to 136. So now I need to divide both sides by 34. I wonder if I can move this over a bit. And let's see what we get. Well, that turns out to be 4. X equals 4. Is this my final answer? Do I put a box around it? No, this is not my final answer. I will not put a box around it. So we have to look and see what we are supposed to find. We're supposed to find the measure of angle QPR. Okay, so QPR. Alright, so that's this right here, the 26x minus 2. That's what we're supposed to find. Alright, so the measure of angle QPR is equal to 26x minus 2. But that's 26 times 4 minus 2. So that is 102. And that is the actual answer, and we'll put a box around that. Okay, so that was the answer to number 7. Okay, number 8. We're supposed to find the measure of arc RB. Alright, so let's mark our target. Arc RB is this arc right here. Okay, that's what we're trying to find. Okay, now which formula am I going to use? No. There it is. Alright, this is an angle outside of the circle. So its angle equals arc minus arc divided by 2. And it's got to be the big arc minus the small arc so we don't get a negative number. Okay, so I've got this, and then I've got this. These are the 3 things involved. Okay, so I'll set it up. Angle equals big arc minus small arc divided by 2. Now, which part of this is the angle? Which one of these is the angle? Is it 60 degrees? No, that's an arc. That's one of my arcs, man. The angle is this up here, 5x minus 10. So that has to come first. So we will say, okay, 5x minus 10, the angle equals. Alright, now, which one of these is the big arc? Alright, it's the one we're trying to find, the fuchsia one. 13x plus 7. Okay, 13x plus 7. Alright, that's the big arc. Now we need to do minus the small arc. Well, I guess I didn't really need the parentheses because the small arc is just a number, 60 degrees divided by 2. Okay, so the angle equals the big arc minus the small arc divided by 2. So it's just a matter of simplifying this. Now there's nothing in front of these parentheses, so I can just erase them. So first I'm going to combine like terms here. So that's going to give me 5x minus 10 is equal to 13x. Okay, and this is, I'm combining positive 7 and negative 60, so that's going to be negative 53. Alright, next it's time to multiply by the denominator. Alright, that way the denominator gets canceled out. Don't forget to distribute the 2. So that's going to give me 10x minus 20 is equal to 13x minus 53. Alright, I see these x's on opposite sides of the equation, so I want to get them together. So I'm going to subtract 13x from both sides. Okay, so that's going to give me negative 3x minus 20 is equal to negative 53. Then I would add 20 to both sides. So that's going to give me negative 3x is equal to negative 33. Okay, so then I'm going to divide both sides by negative 3. And I'm going to get x is equal to 11. Alright, but again, that is not the final answer, because this was our target, arc RB. Alright, not just x. So let's get about it. So we need to find the measure of arc RB. And we know that that is 13x plus 7, so that's going to make this 13 times 11 plus 7. That's 150. So that is the final answer. The measure of arc RB is 150 degrees, and that was number 8. And I'm going to go ahead and stop this video here, and I hope it's been helpful to you. This is just part 1. There are several more problems coming in part 2. So I hope I'll see you then.